In this video, we're going to talk about an application of moments. Specifically, if you want to determine the moment created by a force about a specific axis. So in a lot of engineering applications, motion is designed to be restricted to occur along only a single axis. So for example, the nuts on your tires are only allowed to rotate about the wheel studs, are not allowed to rotate about any other axis. So if you want to determine the moment about a specific axis, we can use the following equation where for I guess specifically for this case where if you were trying to loosen a lug nut on your tire using the L-shaped wrench that's shown in the picture, the moment about the y-axis in this case, which is the only axis that the bolts can rotate about, would be equal to the force applied by the operator of the machine times the distance to the y-axis, right, which is equal to d force times d and then cosine of theta, where theta is between the negative x-axis and the length from the origin to where the force is being applied. Right? In general, we can define the moment about an axis, about any axis, as the force times the distance, the shortest distance to the axis, from the axis to the force that's being applied. Alright, so, and then the last thing is that you can use the right hand rule in this case to determine whether or not the direction of the moment. So, in this case, the moment that's being applied by the force would be a positive moment. It would go about the positive y-axis based off the right hand rule. Alright, so the second, so you can also calculate the moment about an axis using a vector. So in order to do that, we can use the dot product. So we can one of the applications of the dot product is that you can find the projection of one vector along another. Alright, so in this case, our two vectors are, our first vector is the moment, alright, which we can define a moment about the origin, which we can define using r cross f, right, where r is our position vector and our f is our force vector. And then the second vector would be the axis, right, our specified axis. So in this case, our specified axis would be just the unit vector j that goes along the y-axis. Okay, so the moment about the y-axis would be equal to j dot r cross f. Okay, so if we plug in terms for the moment about the x-axis plus the moment about the y-axis plus the moment about the j-axis, moment about the z-axis, what we end up getting is when we distribute that dot product in, you get I dot j dot I, which is equal to 0. We get j dot j, which is equal to 1. And we get j dot k, which is equal to 0. So we end up getting m of y would be equal to just m o y, which makes sense. All right. So in general, if we might have an axis that's not along, not as simple as just the y-axis that we're trying to find the moment about. So in that case, we can specify our axis using a unit vector. So we can define our axis using a unit vector, and we can take the dot product of that with our moment. Right? So what this looks like, if we put everything into Cartesian form, is the moment about an axis we can define using this dot product of our cross product of R and F. We can rewrite this dot product using a single determinant where we say the moment about an axis is equal to the uh, uh, dot product times R cross F. But we can it's really nice that you can write it as a single determinant. It saves you a little bit of time. You don't have to take the determinant of the matrix first and then do the dot product. So the one thing I would like to point out here is that this M of A is a scalar number. It is not a vector. Okay. So if the number turns out positive, what that stands for is that the moment goes along the axis, the defined axis direction, and then if it's negative, the moment goes uh, so, so so using this formula here, just to recap, our scalar, it's a scalar number, not a vector. So if you take the dot product of the cross product to determine the moment about an axis, that the moment about an axis will be a scalar number. It will be positive if it goes along. The axis direction will be negative if it goes in the opposite direction. So sometimes you might be asked to write that moment about an axis as a vector. And in that case, what you have to do is you have to take the dot product of you have to the moment about an axis as a vector. What you'd have to do is you'd have to multiply M of A, which is a scalar number, by the unit vector of the axis. So, and then the last thing I'd like to take point in here is that if you have an axis that goes from, let's say, it goes along this direction. All right, so this is our axis, and we'll define our unit vector that goes along the axis. Okay, and we have a force that's applied to our rigid body. All right, we can define our moment as defining our moment as R cross F. Now we can select R to be at any point along the axis. So it can go from this point to this point, or it could be from this point to this point, or it could be from any point along our axis all right, and you will get the same answer for the moment about the axis. Basically, as long as R starts on the axis and it ends on any point on the line of action of the force. It is acceptable to use as your position vector. Alright, and that concludes this video on the moment about an axis using the dot product times the cross product of R and F.